चलो.
Good evening, everyone. Myself Priyanshu Jaiswal, and me and my team is going to give a presentation on a topic named vanishing point. Let's take a knowledge about the what is vanishing point. A vanishing point is the point where the perspective where the perspective projection where parallel lines appear to converge when extended into a distance. Here we can see that a person stand on the railway track, and the person can see a railway track meets a point. That point is called vanishing point, and this vanishing point occurs, that plane called perspective plane. When now vanishing point where there is two types of vanishing point. First one is principal vanishing point, and second one is trace vanishing point. Principal vanishing point occurs when the lines are parallel to the main axis. It means the object is parallel to the horizontal reference. And trace points occurs when the object is tilted to the main axis. It means here we can see that this is the parallel axis, and that object is parallel to that main axis. It means it will make a principal point, and this here we can say that that object is tilted to the main axis. It means it will make trace point. In the here we can see that this is the principal vanishing point, and this is the trace vanishing point. Here this is the x-axis and this is y-axis, and this object is parallel to the, and we can see that all the vanishing points are parallel to the main axis. It means it is principal vanishing point, and here we can see that this is the x-axis, this is y-axis, and these all vanishing points are the tilt to the main axis. It means these points are trace points. Next.
I'm Pachali. Now I'm going to talk about the methods to find the vanishing point. The first method is the intersection of parallel lines. Like Priyanshu says that when the parallel lines begin extended, they meet at a certain point, and that point is the vanishing point. So in this method, we extend the parallel lines and in the 2D projection, and where they meet, this is the vanishing point. And the next method is the transformation method, where we find the transformation matrix and the infinity point in x, y or z axis, and then multiply them to find the vanishing point. Now, next.
So now I'll talk about the line intersection method for finding vanishing points. So in this example, I have taken two lines which are whose transformation matrix is as follows. Now we will use these position vectors to find the equations of both the lines, and basically in the line intersection method we find both of the equations and equate them and find the value of the x. So on equating these two equations, we can find the value of x as x is equals to 1.444 and y is equals to 0. This is our vanishing point with respect to x, and we can do the similar process for x and y axis too.
Left.
Hi, this is Raman, and I am going to describe about second method to find vanishing point, which is transformation method. This is method it is a more precise technique, involves applying a transformation matrix to point at infinity on the principal axis. So we have four points going to be like x-axis, y-axis, and z-axis, and omega axis. And there's a transformation matrix given. It as follows. We have a transformation matrix, and we are going to find a vanishing point along x-axis, y-axis, and z-axis. So here's an example given, which is going to be as follows. We have transformation method where we have to find by going step by step, and we have given points along x-axis, y-axis, and z-axis. So in step 1, we have to perform scalar product with the transformation matrix and the points to which axis you want to find a vanishing point. So in step 1, we have to find points along x-axis. So we have points given along x-axis, which is going to be 1, 0, 0, 0, and transformation matrix is given as follows. Like this, we have then we will get points along x-axis, y-axis, and z-axis, and omega axis. We always get omega is equal to 1. Ensures projective coordinates, convert these coordinates back. The transformed vanishing point along the x-axis becomes, and by equating we get points along x-axis as 0,8,6, 0.866, 0, minus 0.5. in step 2 we have like in similarly like we can find points along y-axis, z-axis by like when we are going to find along y-axis we have points like 0, 1, 0, 0, and by performing scalar product with the transformation matrix we get points along the along the we get point along y-axis as minus 0.354 comma 0.707 point minus 0, 6, 1, 2, and similarly we going to find point along z-axis as follows. Like we have given point along z-axis as 0, 1, 0, and by performing scalar product with the transformation matrix we going to find the point as 0, 0, 0. So the final result going to be like along x-axis, y-axis, and z-axis. So along x-axis we have given as points along x-axis is 0.8, 6, 6, and along y-axis we have along z-axis. Okay.